So I put a record on, so when we review this homework, so when you find the wrong one, come back here and check what are we doing. Brian, what's the pencil? Oh, I finally forgot my pencil here. Oh. Okay, so let's begin a review homework. And firstly, so let's first, before we review our homework, let's see, refresh our memory. What we learned from last week? Actually, we learned just 2 topics. First is about function, right? Function, right? About function. We want to introduction of function. Where the notation is, we write it like this, right? Actually, this is also generally we say the y, the second variable, just like this is the variable. And after this function change and generate a y, right? So this is called function. So this is the notation of the function. And what the possibly x can goes to, we call it range. Just on any possibly x can change and can be getted, called range. I'm sorry, it's domain. It's the domain. This is the domain. And what a y, just what the f of the function, what a big value or put in a group, we call it range, right? So notation, this is a domain and range. Another important, when we say function, when one input x, only one output y, only one output y, right? So this is the first topic. The second topic, we introduction about try to get the distance of 2 pairs of 2 points, right? So suppose here is x1, y1, here is the first point, and x2, y2 is the second point. For the week before last week, use the 2 point, we can find their slope, right? Find slope is y2 minus y1 over x2 minus x1. This is their slope, right? And you can got their line, linear equation. So you know the slope, you can pick any one of the point, you can got a y minus y1, we're supposed to pick the first one. So, and the m, x minus x1, right? We get a linear line. So this is 2 we learned the week before last week. And last week we learned is if let these 2 dots, how we find the distance? The distance of these 2 points, we say 1, 2, distance between these 2. So the distance is based on y2 minus y1 and square plus x2 minus x1 square and square root of them. Square root. So this is based on the right triangle method of parallelogram theory, right? The third side, just like A, based on this right triangle, one side is A, the other side is B. You can go to C, the other side. The other side square equal A square plus B square. Right, this is rule based on so C is so actually this formula is come from this part. All right, so this is the 2 topics we learned from last week. So let's go through the use our homework to review quickly. All right, okay. So see the example below. We can see here this function is they have this kinds of changing. So find the f pi. If x is pi, x replaced by pi. So all the rest would be replaced by pi, right? So this is function. If the fx function fx is x squared plus 2x plus 1. So when you exchange by pi, replace by pi, or x will replace by pi. So you got f pi is equal pi squared plus 2 pi plus 1, right? So somewhat just like introducing x, it's do this kinds of transformation. You got output fx is what? Is this part, right? So when the introduction x is pi, your output is this one. Let's use, this is an example here. So we can do the homework this part. So f2, so f2 just x replaced by 2, right? 2 times 2 times 2 plus 7. So got 11, right? So fa equal 2a plus 7, right? Because so they give the definition of this function is 2x plus 7, right? The C85 is this gx. The gx also kinds of function. This is sometimes use the f, sometimes use z, you sometimes use h. It doesn't matter, right? These kinds of function, function, right? So here is fgs, the x replaced by s. So this is super easy, right? Just replace here. gr, so for 3r plus 12, right? Okay. So here is h3. So h is this function. So it's 3 became 3 squared plus 7. So 9 plus 7, 16, right? So h, so became a squared plus 7, right? So because of this one, well, variable actually is a right now. So we just a replaced by x replaced by a. So you got this part, right? All right, let's go more. 87. So this part, this function is x squared minus 12. So the function 12 is 12 squared minus 12, right? So 144. So there 144 minus 12, 132, right? Here equals a squared minus 12. So you can understanding actually this is the function, this is the variable, this is output of them, right? Okay, so let's move down. Any questions to this part? Anyone have question to this part? Nope. Okay, so move down. Let's move on. Let me clean the screen. Okay. Let's see the 95. Let me see this part. Let me see the right part. Oh, no, let's go down here. Go down here. Okay, see 95. This is the same as before, right? So we here following function. Given the following functions, find the indicated function values. Actually, just same as before what we're doing. So I just like to have you guys familiar with this concept, and at the same time familiar with this kinds of process. Right. So f0. So given this fx is already defined here. So f0 equals what? 6, right? Because of 0 replace here. F negative 2. So here be negative 2 times, here part is negative 2 plus 6. So here got 4 plus 6 got 10, right? F half, this half, so negative 2 times half plus 6. So we got a 5, right? All right, so C96, the h function, hx equal negative 5 minus 3x. So h2, so h2 is negative 5 minus 3 times 2, right? So negative 11. Second one, function x actually is negative 3, so it's negative 5 minus 3 times negative 3, right? So here got 9, 9 minus 5 equal 4. Right? What about h0? So 0 is negative 5. That's easy one. So because minus 3 times 0, right? So just totally get this part. Okay. This is 97. Gx, this is one of function x squared plus 12x. So G3 equals 3 squared plus 12 times 3, right? 36 plus 9, 45, right? Second part, B, G negative 5. So negative 5 squared. So you x replaced by next 5, right? And plus 12 times negative 5. So here is 25 minus 60, right? So got negative 35, right? All right, so C, G 0, 0, you can see 0 square plus 12 times 0, got 0. Yeah. So this would be relatively easy, okay, for everyone, right? All right, let's move more. 98, hx equals 6 minus absolute x. That's absolute here, absolute here. So here h negative 1, it means 6 minus negative 1 absolute. So here is 1, right? So you got 6 minus 1, you got 5. The second part, h1, 6 minus 1 absolute, also got 5, right? Let's see, x is negative 4, so 6 minus negative 4 absolute, so 6 minus 4, so you got 2. All right. Okay, so let's, this part, find the domain of each function. Domain is the x possibly range, right? So you can see this part, a function equal 2x plus 7. This is a linear line, right? Linear line. So x can be negative infinity to positive infinity, right? So for this part, let's see 100 here. Gx equal, this is actually is the rational expression. Rational expression. This is like a fraction. The denominator and numerator. So denominator part cannot be equal 0, right? So this part x minus 2 cannot be equal 0. So x cannot equal 2, right? Other than that, other than x equal 2, the rest would be fine. The rest would be fine. So what's possibly domain is negative infinity to 2, right? And is u here, 2 to positive infinity, except 2, right? Except 2. All right. So domain, we find it. All right, let's see this part. Let's see this part. Find the domain and range of each function graphed. So let's part. So you need to find the first, you need to find domain, second one, you find range. Let's see the 101. Let me zoom in a little bit. Just keep it as it is. Let's let me see. What can I do? So anyone have question to this part? Anyone have question to this part? Anyone have question to this part? No, I will clean the screen. Clear drawing, clear my screen. So I will move down a little bit and zoom in a little bit. Everyone can see here, okay. All right, see 101. Firstly, we need to find the domain. Domain, you can see this graphing is a linear line, but they didn't extend it outside. So that's only in between. And the 2 dots here is including, right? This black dot. The black dot is fill dot. It's fill dot. So it means including. So the domain from the x. So see the x aspect. The x is from -3 to 5, right? -3 to 5. So here is -3 to 5. They use the bracket, right? They already use the bracket here. So you just need to fill -3 to 5. What's the range? Range from -4 to 2, right? -4 to 2. You can see that this one is -4 and here is 2, right? So here is -4. I'm sorry, -4 to 2 and use the bracket as well. All right. Let's see the second one, 102. 102 here. So see, this is actually parabola. We will learn this later, all right? So that we can see what the happening here. So actually this parabola, this actually continue growing, right? This is draw arrow here, actually is will growing. So for the x-aspect, this keep growing. So x-aspect actually from a negative infinity to positive infinity, right? So here is a parenthesis, negative infinity to positive infinity. X can be from this end to right end, right? Possibly, possibly. What about a range? Range means y. So y never at the under this x-axis, actually above this x-axis, including this dot, right? So will be bracket from a 0. Minimum is 0, right? Minimum here is 0, and go positive infinity. They will go up, right? So the range of the y should be like here. So here is 0, and here is 0. Here is net positive infinity. They go go let the infinity end. So here usually bracket, left bracket is right parenthesis. All right, let's see 103. So see this bar, this is vertical line for the, since it's that's only one dot. So only one dot. This is 3. This is usually this kind of thing. 3, only 3, right? Only one of them. The range of y is means negative infinity to positive infinity. Right. Let's see the 104 here. So you can see what the x range, x domain, they could be negative infinity to positive infinity, right? Negative infinity to positive infinity. And the range actually from here is 2, right? To negative infinity, 2. Let's use a bracket. They already put a bracket here. To negative, oh, sorry. Wrong one. We know that one is negative infinity to 2, right? Why we need a negative infinity first? Negative infinity is small, and this one is bigger, right? So we should put the negative infinity in the left. We cannot write 2 to negative infinity because the negative infinity is less than 2. So we cannot write like this way, right? This is wrong. So we should be saying negative infinity to 2. All right. Okay, so let's move on. Let's move on to the right part here. Okay. Determine which of the following are functions. Just like we say, functions, only one input, only one output, only come out one y. When you put it 1x, come out 1y. Sometimes can this call function. So let's see this one. So here you can see 87. When input is x7, output is 1. When input 7, this one come out with 5. So you input 7, it possibly come out 1 and possibly come out 2. So this is non-function, right? This is non-function. The output is 2. This 7 input 7, you possibly come 1, possibly come out 5. So it doesn't matter this one right now. You already, this 2 is doesn't matter the requirement for the function. All right. Let's see second one, 88. All right, so the input is 1, output -1. Input 5 come is -1. So they are still one output. The output can be the same. Like here, 0, output is -1. 5, output is -1. When you 2, output is 2, right? For this case, someone may have some questions, say, well, why the -1 is the same? Is it possibly a function? The output is 1. The output can be the same. This doesn't matter. But if you input 1, come out two different data, like this one, they are not function, but this one is a function. All right. This is a little bit confusing. Sometimes maybe confusing, but just keep this in mind. When you input 1, output is only 1. But the input is different, output the same, it's okay. it's okay because of when each one the input, the output is 1. Okay, so this is function, right? This is function. All right, let's see 89. 89 here is a linear line, right? We can see this one is linear line because you do the proper transform. You can see y equals, this is linear line, y equals 7x minus 1 and then divide 6, right? So this is linear line. So this is a function. What about 90? 90 y equals 7. This is horizontal line, right? Horizontal line. This is horizontal line. Horizontal line is a function. All right. 91 x equals 2. This is vertical line, right? You can see quickly get this one is vertical line. 91 is vertical line. We know the vertical line input 2, x equals 2, output x is all many different numbers from the negative infinity to positive infinity. So this one is not a function. Output too many. All right. About 92. 92, y equal x power 3. Y equal x power 3. Actually, if you can graphing, you will be like, you can graphing like this. It should be like this. And 1, and they equal 1, and then 2, they equal 8. 2 equal 8. They will graphing like this one. So you when you input 1, output only 1. So this is only this is function. So this is function. This is function as well. 93. 93. 93. Before I move down 93, I'd like to ask, did you guys have question to the 87 to 92?
No.
No. Okay, so I clear my screen. I move down a little bit. So that's critical for this kinds of drawing. So what we can see here? See 93 here. So you can do like this way. Say you input some data actually is list dot data. All right. So these kinds of graphing like this. Right. So when you use something, input x is right here. Latent output is 1 output, 2 output, 3 output, 4 output. You can see this one. You put a 1x data. You possibly have this y, this dot, and this dot, and this dot, and this dot. So over 2 is not only 1 output, right? So this is not function. Yes, if you put it right here, you can see this one output. How many output? It has 2 output, right? What about this one? When you do this vertical line, what 1 output, 2 output, 3 output? What about this dot exactly next here? When you put 1 input x, you can see let's have 2 output, right? There's 2 output, there's 4 output, this is 3 output, this is 2 output. What about this one? No output. No, so we didn't consider this area, right? We consider any possibly have over 2 output. That's why this one is not a function. All right. All right, what about, let's see 94. So this one is flip over 90 degrees. So we can like this one. So what is, we check this one. So when we put 1x here, only 1 output, right? So you won't, what about here? Only 1 output. What about here? Only 1 output. When you're here, you put x, they generate 1 output, right? When you go here, you only generate 1 output here. When you put 1x, only 1 output. When you put this 1x in, you only 1 output is right here. So you can see this one, put any one of the x inside, generate only 1 output. So in this one is a function. 94, this is a function, right? So this one is better explanation. What is a function? What is not function? This is function. This is not a function. All right, let's move on. 95. 95 here.
95 is the same as like the rest of the questions are the same as the other side of the page.
Oh, okay. So duplicate, right?
Yeah.
Okay, let me clear this one. Let me see. Yep, exactly. You are right. So it's a left part. So yep, this part is duplicate or left part. So we don't need to. So you guys sometimes if you do duplicate, you can notice duplicate, you don't necessarily do this part. I'm sorry I didn't cut this part off. All right, so let's move down to second topic. What did we do earlier? Second topic, we talked about the distance between two pairs, 2 points. Actually, each pair here has 2 points. So when one have 1 point is this one, and second point is this one. When we're graphing into the XY plane coordinated system, so you can see, we'll say X1, Y1 is right here. X2, Y2 is here. We find the distance between these two, right? While distance between two. So actually we do some additional line. Additional line here is like this one. So we can see this part and do this part. Like well, geometry, like a triangle, right triangle, right? So this part, the distance here from X1 to X2. So the distance here is X2 minus X1, right? So you of course add absolute value. If this distance between these two, actually, you don't know which one is left or right, right? Actually, but right now you add absolute, it definitely means the distance in X-ray direction, this two is X2 minus X1. Sometimes X2 is bigger than X1, so it's positive value, but as X2 is less than X1, it will be negative value. So you can add absolute value between. So the distance between these two dots actually is absolute X2 minus X1. And for this part is Y2 minus Y1, right? We also add absolute value. So you can see this is right triangles, right triangles. Right triangles, if you know one side and go to this side, and you know the hypotenuse, this side, hypotenuse, this side, C. They have this kind of relationship is A squared plus B squared. The two sides of this right triangle, the square of them equal the third side square. So, all right, so C, this means square root of this part. When you take this two off, take this square off, is square root the rest part. So you can see the distance of these two dots actually is from A square. A is X2 minus X1, right? Square. The Y2 minus Y1 is the B, right? So B, this is A, this is B. So we just need to use this formula for to get the distance between the two dots. All right, so the rest would be easy since we have this in mind. Keep this in mind, we can do it easily. All right, so we do this one very quickly. So see the distance of these two equals. So if you cannot remember it, sometimes I met some situation, some people just mark like this way. Confusing like before. I just tried to. Sometimes people mark like this way. I met this situation before. So let's say this is X1, this is X2, this is Y1, this is Y2. That's not correct, right? That's wrong marking. Don't mark like this way. So here should be X1, Y1. We always like a pair is XY is a match, right? X2, Y2. Because of from, I don't know which year I teach 5 years. And so I met some situations, some people mark like this way. Please don't mark like this way. This is wrong, right? This is correct way. This is wrong way. So X2 is -1 minus 7 square plus Y2. Y2 is -4 minus 3, all right, square. So you can get A square plus 7 square, all right? So you can do the rest of them by yourself, all right? So 64 plus 49, right? So you can quickly get a 113, right? Square. You can keep it like this one. You don't. If you have a calculator, definitely you can get more result. But if you're not, just keep it like this would be good enough. Second one. All right. So the distance between these two X. So x1, y1, x2, y2. All right, this is the correct way to mark it, not x1, x2. All right, please keep this in mind. So x1, x2 minus x1, x2, y2 minus y1. Right, so you got a 9 square plus 5 square. I mean, not 6, here is 6, right? Not 9. So 36 plus 25. 36, 25, 61, right? All right. All right. Any question to this part? Any questions, gentlemen and ladies and gentlemen? All right. So distance between these two, all right, is 3 minus 6, right? Negative 5 plus 7, right? Minus negative 7, so good. Positive 7. So after that, you can get is 3 square plus 2 square, right? 9 plus 4, 13. All right. The distance between these two here is 0, right? So 5 minus 5, negative 6 minus 1, so you got 7. So here is 7 squared, so that's 49. 49 square root, it would be 7, right? All right, for this part, so first is negative 8 minus 5 square plus 6 plus 8 square. It's a little bit bigger, right? 13 square plus 14 square, right? So the rest, can you guys do the rest? Let's go to number 6. So this part. So first is negative 4 minus 4. So you got 8, right? Here is negative 3, you got 9. Negative 3 minus 6 got 9, right? So you can got the rest. All right. So I keep this one to yourself. You can do the rest. Okay. Do you think this is a challenge, everyone? Do you think this is a challenge?
Not really.
Did you learn this before in some other classes or in your current classes? In your current middle
My
school?
brother.
Your brother did?
Yeah.
Okay. Max, your brother did it, right? Okay. All right. So if you didn't learn it, so it means new to you, new to everyone. That's good. So when you learn something new, I hopefully can teach something new to everyone, because I don't like to always review our pre-algebra kinds of class, right? All right, so this time for number 7, let's move on 7 and finish the rest. So this part, we quickly, since we know that one in your mind, right? So this one, negative 2 minus 7 here, minus negative 7, so you got a 5, right? 4 minus 0, here got a 4. 25 plus 16, 41, right? Quick. So we can get even quicker. So if you have this in your mind, in the formulation in your mind. So 1 minus negative 4, 5. Here 4 minus equals 7. So 49 plus 25, 74, right? All right. So here the same, negative 6, negative 2. So you got a 4, right? Here is got a 10. You got 116. Right. So here would be very quick. So you can do this very familiar. And I don't think it need, if you have this in your mind, you don't think necessarily spend so long time to do homework, right? Because you know that. First, 0 plus 6 minus 6, so 6 squared. Here is negative 6, 2, so got 8. So actually got 10. Right? All right, so homework part review is done. So any questions? If no questions, let's take a 5 minutes break and come back. All right.
5-minute break, Jaden.